In today's video, we'll check out the pidog, a Raspberry Pi powered robot dog that is packed with a bunch of features and sensors. We'll start out with a brief unboxing, then try out a number of its features. One thing that you may find very impressive is that you can integrate the pidog with ChatGPT. Not only can it talk back to you, but it can be used to control the pidog itself. After that, we'll go through a full assembly of the pidog. Yep, all 74 steps, as well as how to calibrate the pidog. As a result, this video is much longer than most. I placed chapter markers down below so you can jump around and watch what you're most interested in seeing. I've marked this video as sponsored because Sunfounder sent the pidog to me for review. No money exchanged hands for this video, and all opinions are my own. Sit back and relax. This is going to be a fun video of exploring what you can do with the pidog. I'm John, and welcome to Wagner's Tech Talk. I would like to thank Sunfounder for sending over this pidog for review. This robot dog has a number of impressive features, such as a built-in camera, 360-degree sound detection, ultrasonic sensor, touch sensor, LED strip, and much more. You will need a Raspberry Pi 3B+, a Pi 4 Model B, or a Pi 0W. I'll be using a Pi 4 Model B with 2 GB of RAM. When you open the box, you'll first be greeted with the 74-step instruction manual. It'll be up to you to build the pidog, and it will take quite a bit of time. It took me roughly 3 to 4 hours to put together, but some of that was to record the assembly. If you enjoy tinkering with electronics, then you'll really enjoy this kit. Inside the box are 3 smaller boxes. You'll see all of these parts later in the video during the assembly, so I'll move quickly through the unboxing. Box 1 includes the metal frame and acrylic pieces. The second box contains the servos as well as this RGB strip, a touch sensor, the main Pi hat that includes a speaker and a connection to the GPIO pins, a 6 DOF IMU or degrees of freedom for balance, as well as a camera, an ultrasonic sensor for determining distance, a number of servos, a pack of servo arms and hardware, and all the screws, standoffs, washers, and nuts you'll need for assembling the pidog. There is also this sound direction sensor, so the pidog can determine which direction the sound is coming from. In box 3, you have the 2000 milliamp hour battery, a bunch of cables, wraps for the wires, a camera cable for the Pi Zero, a wrench, and 2 screwdrivers that have a magnetic tip, which will come in very handy, as well as some Velcro for the battery. 2 things that aren't included that you'll also need is a micro SD card for installing the operating system and the Raspberry Pi. Now let's check out some things that you can do with the pidog. Before we delve into the assembly of the pidog, I'm sure you want to get an idea of some of the things that it can do. Documentation for the pidog is good, really good, and I'll place a link below where you can check out the examples and tutorials if you want to explore deeper. To start, there are a number of example programs that can be easily run. You can remote connect to the Pi on the pidog using SSH or shell commands. One that I used frequently for this video is Pi Connect. I'll place a link above if you're interested in using it. It gives you full access to a desktop environment running off the pidog. While the video discusses the Pi 5 mostly, Pi Connect works just fine on a Pi 4 also. Anyway, let's kick it off with some example programs that you can run on demand. We'll start off with some of the more basic commands, such as set. And yes, the pidog can even do push-ups. Its head is very articulate and can move in most directions. What would a dog be without a wagging tail, right? It can also detect being picked up. although in this case he was a little slow doing so. It can also go on patrol and will start barking at an object in its path. Balancing is another interesting feature of the pidog. This one was pretty cool. It can even handle face detection. Let's check that out. As I moved my head, the pidog camera would follow me. The video that you see here was what the pidog was actually seeing. If you want to manually control the pidog using an Android or iOS app, you can download the Sunfounder controller from the associated store. There you can connect to the pidog and even view the video feed. Let's take a look. Now we'll take a quick look at the app. Using the touchscreen, you can move the pidog in any direction, move the head independently, perform specific functions, or get an indication of the distance of the object in front of it. Sit. And here the pidog decided to show out in front of his new buddies. Sit. Come here. Sit. Speak. Speak. Here you go. Good dog. No, no. This one's speaking. You're not. Ow. Sit. Speak. You can also integrate ChatGPT with the pidog. The instructions on the Sunfounder website will step you through the setup process. It took me about 20 minutes to get set up and running. I did need to create an account with OpenAI and run various commands on the Pi, but the documentation steps you through everything you need to do. If you want to use ChatGPT a lot, you may need to add some money to the account. I added $20 and it's only taken a few cents off during my testing. One thing I want to mention, there is about a 10-second delay between the time that you ask a question and the point in which the pidog responds. In this segment, I cut out that delay. Also, the pidog doesn't have a microphone built in, so I added a cheap USB mic which was detected by the Pi. The integration of ChatGPT with the robot is actually really impressive. The assistant you set up thinks it's a robot dog, and it responds that way. We'll ask it a bunch of different questions and see what it says and does. Sit.
Sitting nicely, like a good mechanical doggo should. What's next? Want to throw a figurative stick? Or maybe I can fetch you some witty conversation?
High five. Shake your head.
No. I'm all about the positivity here. What's shaking? Got any more fun commands, or should I keep my head at a steady state of awesomeness?
Pant 5 times. Lay down.
Lying down like a good mechanical pup. What's the next fun topic you want to dive into?
Are robots going to take over the world?
Ah, the classic question. Don't worry, I'm just here to help and entertain, not to take over. Think of us robots as trusty sidekicks, not world conquerors. We prefer fetching sticks over dominion. Thank you very much. Your inner Picasso is about to unleash some creativity on that canvas. Just remember, if you need any motivational barks, I'm here to cheer you on.
What's this a picture of?
That looks like a cozy little house with a chimney. No pig in sight, but maybe it's a house waiting for some pigs to move in. Are you planning on adding some porcine friends to the picture?
Tell me a joke.
Why did the dog sit in the shade? Because he didn't want to become a hot dog. Now that's some punderful humor.
Scratch. Walk forward. Walk backwards. Follow my hand. Bark like a dog 4 times. What is your battery percentage?
Just checked, and I'm running at a solid 100%. Ready for action and adventures with you, my friend.
In this segment, we'll assemble the pidog. To get started, open the package containing all the hardware. Steps 1 through 5 are slightly different if you'll be using a Pi 0. In this video, I'll only be showing the steps for the Pi 3 or Pi 4, and I'll be using a Pi 4 for this build. In step 1, take plate A, locate the sound sensor module. In addition, we'll need 4 M2.5 by 8 plus 6 standoffs and 4 M2.5 by 6 screws. Place the screw from the bottom of plate A towards the top, then the sensor module through the hole, and then screw in the standoffs to each of the 4 locations. In step 2, locate the 7-pin wire and connect the white end to the sound sensor. Press in firmly to make sure the cable is seated all the way down into the connector. I'll be using a 2 GB Raspberry Pi 4 Model B. The 2 GB of RAM will be plenty for this robot, and it's a little bit cheaper. Fold the cable over and position the Pi over the standoffs. Using 4 M2.5 by 11 standoffs, tighten them down in all 4 locations. Here you'll find it easier to use the wrench, as some areas are a bit hard to get to. Make sure all 4 are tight, but not too tight, as you might break the standoffs. This is future me correcting a mistake I made earlier in the build. The amber FPC cable is only used for the Pi 0. For the Pi 3 or 4, you'll want to use the blue and white FFC cable that is packaged with the camera. Raise up on the black latch, insert the cable such that the blue strip is facing the USB ports, then press down on the black latch to lock it into place. In step 5, we'll take the robot hat and position the GPIO connector over the pins. Then install 4 M2.5 by 6 screws into the 4 locations to secure the hat. In step 6, take the black end of the 7-pin cable and connect it to the robot hat such that you can see the pins on the side of the connector. In step 7, take one of the servos and position it through the back of plate A. Insert 1 M2 by 6 screw and tighten it with an M2 nut. The wrench can be used for the bottom screw. Then insert the screw at the top. Using another M2 nut, tighten it down snugly. For step 8, take the battery and remove the backing from one side of the Velcro. Position it over the battery and give it a firm press. Then remove the backing from the opposite side and position the battery over the crosshairs at the bottom of plate A. Again, give it a firm press. In step 10, take the cable from the battery, feed it through the notch on plate A, and connect it to the port on the robot hat. Be sure to insert it all the way. Step 11 is all about getting the software set up. On a computer, visit pidog.rtfd.io and select the Play with Python heading on the left. Sunfounder documentation is excellent, and it will step you through the software installation very easily. It will cover what you'll need, how to install the operating system, information about the power supply, setting up your Raspberry Pi, installing all the software modules, checking I2C and SPI interfaces, and servo adjustment. For example, the documentation will step you through downloading PyImager, writing PyOS desktop to a micro SD card. You'll then plug in the USB-C cable into the hat and power on the Pi. Update the operating system and install all the required packages and modules. This part will take probably about 10 or 15 minutes. Then you'll enable I2C and the SPI interface. And finally, you'll run the code that will allow you to perform the servo adjustments or zeroing by running servo_zeroing.py. Just copy the command and paste it into the terminal session and press enter. It's that easy. On the Pi hat, we'll be zeroing servos initially using the P11 port located right here. In step 12, we'll assemble the pidog tail. Plug in the servo for the tail into P11 on the robot hat. Take plate B and the servo arm from one of the many included small servo bags, and then the servo arm through the hole of plate B. Now screw in two M1.5 by 3 screws to hold the servo arm in place. Insert the cable tie into the end of plate B and pull it tightly. Take the smaller servo screw from the bag, position the tail assembly to point straight down over the servo, and screw in the tail to the servo. Take the 4 plate D and the 4 plate C's and arrange them like you see here, paying attention to the location of the rectangular clip areas. Then place 8 stickers on each of the plates and mark them as shown in the instructions with either L or R to indicate the left or right side of the legs. From the side where you placed the labels, position the 4-arm servo piece through the hole. From the opposite side, screw in 4 M1.5 by 3 screws and repeat for all 4 shoulder portions of the leg. In step 16, we'll install the servos to the shoulder portion of the leg. Insert the servo such that the rotary portion of the servo is on the same side as the servo arm and sticker. Using an M2 by 6 screw, put it through the back of the servo and secure it from the front with an M2 nut. Repeat the same for the bottom servo hole. And repeat the same process for all 4 of the shoulder portions of the pidog legs. In step 17, we'll basically perform the same actions as we did in the previous step, however for the bottom portion of the pidog legs. Insert the servo such that the rotary portion is on the same side as the stickers. Insert an M2 by 6 screw through the back and an M2 nut from the front. Then repeat for the other servo hole, and repeat the entire procedure for all 4 legs. Take the package containing all the acrylic parts and locate all of the plate Ds and remove the protective backing from both sides. I found it easier to remove the backing using a small paring knife. Then place one plate D behind and one in front of the leg in the orientation shown here. Then insert an R3090 rivet from the back to the front through both holes to lock it into place. Then repeat for all 4 legs. Take one of the right pidog arms and connect the wire to P11 on the hat. Insert the right shoulder portion of the leg, forming a 90-degree angle, and insert a servo screw to hold it into place. One thing I like to do is to test each of the servos as I go by unplugging it, then move the leg, then plug it back in to make sure the orientation is correct. Repeat steps 20 and 21 for the other right leg. For steps 22 and 23, plug in the servo to the left arm portion, insert the shoulder portion to make a 90-degree angle, and insert the servo screw to hold it into place. Then repeat for the other left leg. For step 24, we'll attach all 4 servo arms to the 2 large plate E's. Take one of the plates and position one of the servo arms from the inside and insert 4 M1.5x3 screws to hold it into place. Repeat the same for the opposite end of the same plate. Then take the other plate E and insert the servo arms from the opposite side and insert 4 M1.5x3 screws into each of the 2 locations. For step 25, take the top shoulder portion of the leg and plug it into P11. Then connect the shoulder portion to the servo arm such that the bottom leg is parallel to plate E. Then attach a servo screw to hold it into place. Again, it's a good idea to test the servo by unplugging the servo, moving the leg slightly, and plugging it back in to make sure it returns to the correct position. Repeat the same for the opposite plate E and legs for steps 27 and steps 28. All 4 legs should now be attached to both plate E's. In step 29, flip the power switch on the hat to the off position. In step 30, we'll attach the legs to the main assembly. Line up the holes for one side and insert 2 M3x6 screws into those 2 holes to secure the legs to the main assembly. Flip the pidog to the other side and attach 2 additional M3x6 screws to the plate to secure the legs to the main assembly. Be sure that both sides are tightened firmly. In step 31, take plate F and attach it to the back of the pidog near the tail using 2 R30-55 rivets. For step 32, take the servo going to the tail, feed the cable through the cutout in the metal frame, then plug it into P9 or power 9. The brown wire goes to the black side and the yellow wire to the yellow side as you see here. In step 33, we'll take the servo wire from the front left shoulder, insert it into the groove, then feed it through the hole at the back of the leg. Insert the cable into the cutout at the top portion of the pidog and pull it through. Then connect it to P2 on the hat. Slightly turn the bottom section of the leg, feed the servo wire through the back of the frame and pull it through. Bring it through the top of the frame and plug it into P3 on the hat. Now take the back left leg and bring it slightly forward, route the wire into the groove of the leg, and feed the cable through the back of the plate. Then up through the top and pull the cable through. Now connect the servo to P0. For the bottom portion of the leg, feed the wire into the groove, route the cable into the cutout on the side frame, feed it through the top portion of the frame, and pull it through. Then connect it to P1 on the hat. We've seen how to connect the servos to the hat for the left side. Now repeat the same for the right side by connecting P7, P8, P10, and P11. In step 35, take the RGB board and insert it from behind plate G. Then install 2 R26-55 rivets to secure it into place. On step 36, connect one end of the 4-pin wire to the left side of the RGB board. Feed the opposite end through the front of the frame, then connect it to the far left front connector on the hat. Be sure it's oriented properly and pushed all the way into the connector. Connect another 4-pin wire to the right side of the RGB board. We'll connect the other end in step 39. In step 38, position the RGB frame over the front of the pidog and insert one R3055 rivet into each side. Then add another R3055 rivet into each side to hold it securely into place. For step 39, feed the left side of the RGB cable through the cutout in the frame. Take the 6 DOF or degree of freedom module and plug in the 4-pin wire into the left side. Using 4 R3055 rivets, secure the module into place. In step 40, take plate H, then flip the pidog upside down and position the plate over the battery. Then insert 4 R3055 rivets into all 4 corners to hold the plate over the battery. If a leg is in the way, move it down to make it easier to insert the rivets. For step 41, we'll assemble the stand, which will be used to minimize servo damage and will be used for the leg calibration procedure later. Remove all the acrylic covers from the 2 acrylic A pieces as well as acrylic B. Take an M3 nut and position it into the B plate. Slide one A in into B and insert one M3 by 12 screw. Then repeat by inserting another M3 nut and M3 by 12 screw for the opposite side. Position the pidog over the stand that we assembled in the previous step. Now, in step 43, take plate I and place a servo arm through the inside of the plate and secure it with 4 small M1.5 by 3 screws on the opposite side. For step 44, power on the pidog, reconnect the USB-C power, and rerun the servo_zeroing.py script as we did earlier. On to step number 45, plug in a new servo into P5, attach the servo to plate I in this orientation, then insert a servo screw to secure it into place. In step 47, insert another servo into the arm on plate I in this orientation. Then insert one M2 by 6 screw through the front and an M2 nut at the back. Then do the same for the opposite end, inserting an M2 by 6 screw and an M2 nut. On step 48, insert an M2.5 by 6 screw through the hole, then insert an M2.5 by 20 standoff and tighten it securely. Take plate J, position it over the servo, then install an M2.5 by 6 screw. In step 50, take plate K, then insert a servo arm, and then 2 M1.5 by 3 screws to hold it in place. Take an M3 by 6 screw and put a spring washer over it, then insert it through plate K and install an M3 by 11 copper standoff. Then repeat the same for the opposite side. In step 52, plug in the servo enclosed in the metal frame into P5. Then attach plate K in this orientation and secure it with a servo screw. For step 54, take plate L, then an M3 by 6 screw with a spring washer and insert it through plate L. Then attach an M3 by 11 copper standoff. Repeat the same for the other hole by inserting an M3 by 6 screw and spring washer, followed by another M3 by 11 copper standoff. In step 55, I noticed during editing I missed a washer between plate L and the metal frame. Using an R3055 rivet and a washer, insert plate L into the frame. For step 56, take plate M and feed a servo cable and the servo through the hole. Using an M2 by 6 screw and M2 nut, secure one side of the servo. Then another M2x6 screw and M2 nut for the other side. Next, take plate N and insert the servo arm through the hole. Then install 4 M1.5x6 screws to hold the servo arm into plate N. In step 58, connect the servo with plate M installed to P5. Insert plate N to the servo in this orientation, that is, the cutout will be on the right. Now secure it with the servo screw. For step 60, simply power off the pidog hat. Now place the servo assemblies like this. Insert a metal washer between the two metal pieces and secure it with an R30-55 rivet. For step 62, secure the servo using two R20-56 rivets. You may find it easier to use a screwdriver to push them down and lock them into place. Take the servo attached to plate M and connect it to P4 on the hat. Take the servo coming from the inside of the assembly and connect it to P5. Now take the remaining servo wire and connect it to P6. In step 64, we'll install the neck assembly to the pidog. Here I used the wrong washers. Instead of the flat metal washers that you'll see here, I should be using the spring washers. However, it wasn't a problem. Using an M3x6 screw and a spring washer, put the screw through the side and into the copper standoff. Repeat the same for the other side to keep it stable while installing the other two screws. You'll need to move the leg slightly, then you'll be able to insert another M3x6 screw and spring washer to the remaining two locations. For step 65, locate plate O and we'll install it to the side. Using two M3x6 screws, attach plate O to the side. Then be sure to tighten both of them down securely. In step 66, we'll assemble the camera. Take the small camera piece and remove the backing. Plug the small connector into the main part of the camera and push down. Then press down on the camera to affix it to the board and remove the protective cover over the camera. On the opposite side, gently pull down on the black tab on the connector. Insert the FFC cable such that the blue tab is facing outward. Then push down on the black tab to lock the cable into place. Take the camera module and insert it to the front of plate P. Then using 4 R20-48 rivets, secure the camera to the front of the pidog's head. On step 68, take plate Q and position it over the holes towards the front of the pidog's head. Then use two R30-55 rivets to secure it to the plate. Remove the adhesive backing from acrylic plate E. Take the ultrasonic module and slide it through the openings in plate Q. Place the acrylic plate E at the back and then insert an M2x10 screw and secure it with an M2 nut at the front. I recommend installing each of the 3 additional screws loosely first. Then once all the screws and nuts have been installed, you can tighten all 4 of them down. In step 70, take the 4-pin wire and connect it to the ultrasonic module. Make sure the cable is seated all the way in. Next, we'll install the touch module. Take the small 4-pin wire and feed it through the metal housing and connect it to the board and push the connector in firmly. Position the module over the holes and using 4 R30-55 rivets, secure the touch module to the frame. In step 72, we'll start by connecting the ultrasonic wires to the hat. Connect the black wire to the black on D0, red to red on D0, white to yellow on D0, and yellow to D1 on the next row. For the touch module, connect green to D2. In the next row, red to red on D3, yellow to yellow on D3, and black to black on D3. In step 73, position the head over the frame and secure with 4 R3055 rivets. We finally made it to the last step, number 74. It took over 20 hours for me to edit just the assembly section. Please don't forget to leave a like if it has been helpful to you. Place all the wires at the back of the head, then position plate O over the head assembly. Now install 4 rivets into all holes except for the 2 at the bottom. For the 2 remaining holes, install 2 M3x6 screws. Congratulations, you've completed the assembly of your pidog. In the next section, we'll perform the calibration. Next, we'll calibrate the pidog. Calibrating the pidog is pretty straightforward. Power on the pidog. We'll use this 90-degree ruler to adjust the angle of each leg. Place the stand under the pidog. Plugging in the power is optional if it's already charged. Since I want to calibrate on this desk, I'll go ahead and plug in a keyboard and mouse to the USB port on the Pi, and the micro HDMI port, here's the USB-C power input on the Pi. I browse to the calibration page on the Sunfounder website. I'll place a link down below. It's under the Play with Python heading. Just copy and paste the command into a terminal window and press enter. The pidog will then enter calibration mode. From here, select the 90-degree calibration ruler. On the right, you'll see a layout of the pidog with various numbers. Pressing 5, for example, will allow adjusting the hip of the left leg, and 6 will adjust the elbow angle. You can then press W or S to increase or decrease the angles. Here's a quick example. You can also calibrate the head and tail position if needed. Once all the changes have been made, press the spacebar to save the settings and press Y. Then, Ctrl+C to exit the calibration routine. I hope you enjoyed this look at the pidog. It is, without a doubt, one of the largest projects I've tested on this channel and one I'm thoroughly enjoying. While the assembly steps are very well documented, it is very time-consuming to assemble. However, the capabilities of the robot are very impressive. I particularly love its integration with ChatGPT, but I would like to see the responses returned to be a bit faster. That said, the tech is nothing less than impressive. If there is anything specific you'd like to see in a follow-up video, please let me know in the comments below. I appreciate you watching, liking the video, and subscribing to the channel. Your support is always appreciated. And with that, I look forward to talking with you again very soon.